Hello everyone, welcome to Botronix Labs. This is Module 1, Distance Drive Challenge in our VEXcode VR Robotics course. In this module, we're going to learn how to control a robot to move precise distances using code and understand how movement relates to real-world measurements. We'll complete 3 small practices step by step. Let's start with our first practice. We are using the grid map playground, where each grid square measures 200 millimeters. Our goal is to move the robot forward 3 grid squares. So first, we convert grid units into distance. 3 times 200 equals 600 millimeters. Now we can program the robot to drive forward exactly 600 millimeters. Let's run the program and observe how the robot moves precisely 3 squares forward. This is the foundation of controlling movement in robotics, being accurate and predictable. Now, let's move on to the second practice. In this task, we want the robot to move forward and then return to its starting position. First, the robot needs to move forward 6 grid squares. Since each square is 200 millimeters, 6 times 200 equals 1,200 millimeters. Next, we need the robot to turn around. To face the opposite direction, the robot must turn 180 degrees. After turning, we command the robot to drive forward again for the same distance. Let's run the program. You'll see the robot move forward, turn around, and come back exactly to where it started. This introduces an important robotics concept, orientation and direction control. Now, let's complete our final practice. We're going to program the robot to move in a square shape. Each side of the square is 3 grid squares, which equals 3 times 200 is equal to 600 millimeters. A square has 4 equal sides, and at each corner, the robot turns 90 degrees. So the pattern is drive forward, then turn, and repeat this 4 times. To make our code more efficient, we use a repeat loop. Let's run the program and observe the result. You should see the robot draw a perfect square on the grid. Today, we completed Module 1, Distance Drive Challenge. We learned how to convert grid units into real-world distance control, robot movement, precisely use turning angles, like 90 and 180 degrees build patterns using loops. These are fundamental skills that every robotics engineer needs. In the next module, we'll explore more advanced movement and navigation techniques. If you enjoyed this lesson, don't forget to follow Botronix Labs for more robotics programming content. See you in the next module.